This mini lesson is on the topic of radicals. Now, what is a radical? A radical is just another name for a square root. Before we get into square roots and how to reduce radicals, we need to talk about our perfect squares, because when we reduce radicals, we're going to be talking about what is the largest perfect square factor of that number. So the perfect squares are just each integer times itself. So the first perfect square is 1 times 1, which is 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, 10 squared is 100, and then of course there's an infinite number of perfect squares. So this I'm going to write at the top of my paper every problem we do, and we're going to look at the largest perfect square factor. All right, here's my first example, square root of 36. I'm going to eliminate any perfect square that's larger than 36, and I will see there that 36 is actually one of my perfect squares. So what number times itself is 36? 6. It's as easy as that. All right, 49. 49 is also a perfect square. What number times itself is 49? 7. Number 3, 81 is also a perfect square. What number times itself is 81? 9. Now, if you're thinking at a more advanced level, you may realize that the square root of 36 is 6 times 6 is 36, but you also may realize that negative 6 times negative 6 is also 36. So when we say the square root of 36 is 6, technically we should really write plus or minus 6. And you're going to be doing that in Algebra 2, so it'd be a good idea for you to learn that now. For our purposes in geometry, all we're going to do this second is just worry about the 6, the 7, and the 9. But if you get into the habit already of knowing that it's really plus or minus 6, plus or minus 7, plus or minus 9, you'll be a leg ahead of what we're going to be doing in this class and what you need to do in Algebra 2. All right, let's do a couple examples that are a little bit harder. All right, once again, I've written my perfect squares across the top of the paper, and now I have the square root of 50. If you look on this list, 50 is not up there. So what's that mean? 50 is not a perfect square. Okay, that means it's not just going to be a whole number. So what I do is eliminate any of my perfect squares that are bigger than 50, because like I told you in the beginning, we're going to look for the largest perfect square factor. Excuse me. And you can't be a factor of 50 if you're bigger than 50. Something that multiplies by another number to go into 50. Okay, now let's go down our list. Is 49 times the number 50? Nope. Is 36 times the number 50? No. Is 25 times the number 50? Yes, it is. Okay? So what we're going to do is write the square root of 25 times what? 2. So square root of 2. So you write 2 square roots, square root of 25 times square root of 2. Now, what is the square root of 25? That's a perfect square, isn't it? What number times itself is 25? 5. Now we have to deal with the square root of 2. Do you see that on our list of perfect squares? Not there, so all we do is write square root of 2, and you're finished. And then what should we put if we want to be mathematically proper? Plus or minus out front. Good, let's do another one. What about the square root of 48? Let's try that one. Okay, we will eliminate any perfect square that is bigger than 48, because if you're bigger than 48, you can't be a factor. And is 36 times a number 48? Nope. Is 25 times a number 48? No. Is 16 times a number 48? Yes. So we write our two square roots again, like we did last time. 16 was our largest perfect square factor. 16 times what is 48? 3. Okay, now what is the square root of 16? What number times itself is 16? 4. Square root of 3. Is 3 a perfect square? Is it on our list up here? No. So how do we write it? Just like that. And then what should we do if we're trying to be perfect? Plus or minus in front. Now some people mess this one up. Very common error, that they don't realize that 16 is a factor of 48. So what do? They say that 4 is the biggest factor of 48. Okay? Let's do it that way. So that would be square root of 48 is square root of 4 times square root of 12. This is how to recover in case you don't pick the largest perfect square factor initially. What is the square root of 4? That's on our list as a perfect square, 2. Now square root of 12. Does it have any perfect square factors? Yes, it does. So that's how we know we didn't go far enough in the first place. What is the largest perfect square factor of 12? 4 times what? 3. So you have 2 times what's the square root of 4? 2. Square root of 3, is that a perfect square? No. So we have 2 times 2, or 4, square root of 3. So we get the exact same answer again, but we went the long way about it, and that's how we recover from an error.